That was really interesting, Andrew. A lot of people ask us and focus on R value all the time, or resistance, thermal resistance. But what I've learnt from what you've said is that wool goes over and above that. It provides a thermal resistance, and on top of that, it's active. So it will provide heating and cooling as required, just as a natural process. What an amazing product for insulation.
Wool insulation just doesn't trap heat. It's an active material that releases a small amount of heat when it absorbs moisture vapour. That's why it's so good at keeping us warm and dry in our homes.
Okay, interesting. Let's look at how that works.
Okay, Grant, you asked. I could bore you to tears for hours on this subject, but wool fibres are unique. They're like microscopic sponges. When there's a lot of moisture or humidity in the air, the wool wants to absorb it all. The wool fibre is made up of proteins that have chemical hookup spots for the water molecules. Now this one is a little bit technical, but when a water molecule from the humid air is pulled into the wool fibre, it's a bit like two magnets snapping together. At this point, a chemical bond forms between the moisture and the wool fibre, and the wool releases energy in the form of heat. This is called an exothermic reaction. Exo means out and thermic means heat. Hey, the result is that wool literally warms itself up when it takes on moisture vapour. This is why insulation is so effective at managing moisture and preventing condensation, which can lead to mould and structural issues. As they say in Japan, sugoi, great. Hey, but that's not all. Wool creates a cooling effect when it releases the moisture that it has absorbed. The process that creates coolness is called an endothermic reaction. Endo means in and thermic means heat. The chemical bond's tiny hooks that we talked about must be broken for the water molecules to turn back into vapour and escape the wool fibre. With an endothermic reaction, heat is literally sucked in. Breaking any bond requires a lot of energy. In this case, the energy must be pulled in from the surrounding environment, which is in the wool fibre itself and in the air trapped in the insulation. And now we have cooling when we need it.
It's a really warm Canterbury nor'west day. I think it's about 28 degrees out here. And whoa, straight away you feel that it's so much cooler in here. G'day Andrew.
Hey Grant, how are you?
I'm good, how are you?
Good, thanks.
You got your air conditioning on?
It feels like it. It's the Forever Breeze system doing its job.